Let's move on to something else. I am just throwing ideas at you and we will merge everything later. I wanted to discuss blue shift and redshift in my universe. We already discussed what I would call extrinsic redshift through the scaling factors effect. The expansion of the grid affects where peaks and troughs land, leading to redshift. Now, I want to see if an appropriate model for wavelength and frequency can predict something about the characteristics of the wave. So let me provide a derivation of the law pertaining to the relationship between wavelength and frequency. I figured I could model frequency as a variable that can be affected by the flow of space only. It would have a partial derivative with respect to the radius that is null, given appropriate assumptions such as absence of refraction, and a covariant derivative that is thus the result of a multiplication with gamma 101 since frequency would be a time-like property that evolves against space. We can also consider the wavelength of a source that emits spherically with the wavelength being a radial property that evolves against time. Thus, the covariant derivative with respect to t would involve a partial derivative of the wavelength with respect to t, which would be null, given appropriate assumptions. I will only focus on the part with gamma 000 in the covariant derivative. Since a free wave would need to have a speed of 1, this means r equals t, so effectively arranging the derivatives, we allow ourselves to write the following equation that relates the change in frequency with the change in wavelength. This, solved, leads to the famous equation, frequency times wavelength equals a constant. Now let us take one of these expressions and see how it affects the frequency or the wavelength. Here are the key curves I would like to share for ease of reading. Some curves have been reflected so as to be visible, because otherwise they would overlap. Watch the signs in the legend to properly read the displayed data. It seems that the wavelength evolves in sort of an affine way from a time later than t equals the half-life of the ultra speed, which tends to suggest a tired light phenomenon. Time t equals half-life could be the moment of recombination in my universe. During the earlier phase, from time 0 up to the half-life, both the wavelength and the frequency are complex. The wavelength's real and imaginary parts are opposite, and behave much like a tired light situation, in a compressed finite value range for time. This means that the curve blows up much more quickly. The frequency being the reciprocal has the same sign for both the real and imaginary part, preserving the fact that the product of both elements is still equal to 1. Before time 0, the frequency has the qualities of the tired light description, mirrored. This fills a lot of gaps and raises a lot of questions as to how to interpret the results. However, it seems that we can actually peek behind the recombination period in my universe. But the interpretation of complex wavelength and frequency are not readily available. Yet, we can use the de Broglie relations and describe the waves in terms of a radial momentum and an energy, which leads to a function of a wave that should be amplified or decaying with time, and/or amplified or decaying with distance. Everything will make much more sense once we look at the implications for the de Broglie relations, and I will be able to show you that our scenario is indeed one of some form of conventional redshift in the positive time dimension. We will be able to infer the generation of massive particles that can only live between time 0 and time equals the half-life of the ultra speed. I suggest that these time-limited particles would be the indigenous ones in my universe, which would have to decay into the standard particles that my universe would later be made out of, for all of my scientists to detect them and build particle accelerators to smash them. Late watchers of the playlist, just wait for this redirect to delve deeper into this topic.